they filtrate water?
They filtrate, they can also ingest bacteria by filtering the water. Yes, there is a movement of water inside the stomach and outside the throat, like this. It's a filtering system, yes, also. And there is a ciliary movement that also brings the bacteria down in the stomach. So they have many different ways of catching food.
So the carbon that they get. So the carbon and nitrogen that they get from zooxanthellae.
Yes.
Which is the mechanism?
This is through transporters or diffusion. For example, ammonium diffuses through the tissue up to the zooxanthella. For nitrate, you have transporters, membrane transporters. Good question. We don't know. Mostly the zoox are. We don't know in fact. We don't know.
I think it's mostly dissolved translocation of dissolved exudates. Yeah, from because they are inside, right? They are inside the tissue, so it's.
But exactly at the membrane of the zoox, we don't know. There was no study done on this, especially because they transfer sugars, lipids, and big molecules, in fact, not just small molecules. So we really haven't seen any study on this. There should be transporters, also sugar transporters or things like this at the membrane of the zoox.
You mean there's no study to see which transporters are?
Yes.
Yeah.
Yes.
Yeah.
Doesn't mean.
But there's a couple of studies with nanosynths that they show incorporation of 13C to the zooxanthellae and then transfer to the.
And the transfer, but how? This was the question.
Yeah.
How it's transferred?
Yeah.
It's just transporters, as in every animals or algae. But which transporters? We have LC, so it's for amino acids. LC transporters, things like this, but not a lot. It's just for molecular studies, but nothing really in particular.
I'll just connect very briefly to your question because I think it connects well to my point, and that's because it's interesting that you showed basically decreased reliance on heterotrophy or decreased efficiency of heterotrophy with decreased autotrophy.
Yes.
But in that case, you showed that with artemia, so zooplankton, right?
Yes.
And in the second experiment, instead, you showed increased reliance on dissolved organics, right? Because you showed that the corals incorporated more organic material from mucus that was released, and then nitrogen incorporated by the diazotrophs back into their tissues.
Yes.
So I think from that we can also hypothesize that the corals maybe they are not actually less heterotrophic. Maybe they are just shifting their food source from a bigger food source like zooplankton to a smaller food source of organics anyway, but dissolved.
Yes,
like,
but it's
like
in
DON,
terms
DOC and DON that is very present. We know in coral reefs, but we don't know much about it. So
but in terms of quantity of carbon and nitrogen that you can get from a plankton and that you can get from microbes, for example, it's really microbes. They seem to contribute a lot because when I show that there is 90% in deep corals of N2 assimilated in the coral tissue, but when you compare to what they can get from dissolved inorganic from the algae or what they can get from just one zooplankton prey, it's nothing.
Mm-hmm. Okay.
The contribution is really, really tiny. So now we can make a budget, but usually what they can get from a plankton is already 10 times, 100 times higher just with one plankton prey than what they can get from inorganic, dissolved inorganic from the algae, and it's maybe 1,000 more than what they can get from bacteria.
But that will depend also on the concentration of plankton and
Of course.
on the concentration of dissolved organic.
Of course, and this we don't really know.
Yeah.
How much they feed on the different in situ, in real conditions, we don't really know.
But it's plausible to imagine, I guess, it's my guess, that they are like less healthy, and maybe they just are not able to catch large preys anymore, but are still able to incorporate some dissolved matter.
Yes. Not always. It has been shown that for the dissolved organic, as you say, sometimes some coral species can ingest and some corals not. They just release even more organic carbon and nitrogen. So this depends on the coral species and on the state. But really in situ, it's hard to do experiments. Yeah.
Can I formulate a question, Christine?
Yes.
Sorry.
Yeah.
It's me.
Sorry.
On Skype. Yeah, sorry. Yeah, thank you very much for your. I'm curious to know if the pattern we have shown, if there are implications for the skeleton growth, and on the long term for the bioconstruction activity and performance of the coral.
Yes. So thank you.
Including the bleaching, that sometimes, which is a very large scale phenomenon. If this is as a repercussion and implication for the growth of the colony and the bioconstruction performance of the reef.
Yes, so calcification is an energy demanding system, so needs a lot of energy. The corals need a lot of energy to calcify. So as soon as they cannot get this energy, the calcification stops. So if there is no input from the algae and this input is not compensated by some plankton, then you will see calcification decreasing very fast, very quickly.
Mm-hmm. Yeah, thank you. And I have another curiosity, and maybe what do you know about soft coral, which are really less studied and neglected? If the same, if you have seen in case the same mechanism in the soft coral.
So in soft corals, nothing has been done, really nothing. So it's why I have my PhD student working on soft corals.
Chloe. Yes.
Chloe, yes.
Chloe, I know. Yeah.
And she just, we just tried. For sure, the soft corals, they don't have nitrogen fixation. They don't release the isotopes in the seawater. And this is due to the fact that the mucus contains too much antimicrobial compounds or things like this. And we were quite surprised, but we couldn't measure any N2 fixation with the soft corals. And this is what Ulysse, I think, and Vanessa had seen also in the Red Sea, that they measured very low rates of N2 fixation in presence of soft corals. So this way is shut down in soft corals. And for the nitrogen uptake by the algae, you need to wait 3 more months. And then I can give you the answer.
Okay, thank you very much.
You're welcome. Thank you.
Okay, 2 curiosities. Besides capturing the zooplankton, the corals can also filter phytoplankton that sinks, I guess.
Yes. Detritus, yes.
Yes, and also sinking phytoplankton cells.
Yes.
And another perhaps crazy question. Is it known whether this cyanobacteria can live inside the dinoflagellates also?
Inside the dinoflagellate?
I don't know.
No, this was a paper by Lesser in 15 years ago, something like this, showing some cyanobacteria inside the coral tissue, not the zoox, just the coral tissue. But I think it was not. Even Ulysse, I don't know what you think, but it was really strange because it hasn't been seen a lot. So now with the NIF-H sequence, we can search for cyanobacteria inside the coral tissue. So we did one work with Vanessa also on the Mediterranean coral oculina, Patagonica. And this one, we found a lot of NIF-H in the skeleton, in the coral tissue, and in the mucus. And we tried to do the same with tropical corals, and we couldn't find a lot of NIF-H sequences.
But
so,
how much of that cyanobacteria in the?
A lot in oculina.
Okay.
Really a lot. It's a high percentage of NIF-H compared to the overall microbial community. In the tissue of oculina, it's really a lot. But it's restricted to some coral species. We tried in the Red Sea to do the same with Stylophora pistillata, and we couldn't, in shallow waters, we couldn't find any NIF-H sequence. And the problem with the coral is the mucus layer. And with sequencing, even if you have a tiny bit of DNA from the cyanobacteria, you amplify and you sequence this DNA. So it's hard to say if it's just in the mucus or in the coral tissue. For this, we need fish in situ hybridization to really know if the cyanobacteria are inside the coral tissue, but fish in corals, it's really difficult because they have a lot of autofluorescence that mask the fish fluorescence. So it's already hard to make slices of corals because you have the skeleton, so you have to decalcify first just to get the tissue and then make slices of tissue and try the fish. But I don't know, maybe there is 1-2 papers with bacteria, not with cyanobacteria, who have tried fish, but it's really hard. So for the moment we don't know with the cyanobacteria, except in oculina, for example, or here we see really a lot of NIF-H and a lot of different cyanobacterial groups. I don't remember, but quite a lot, yes.
Thank you.